Hello everyone, welcome to Theo-MathProblemSolver. In this particular episode, we are going to continue on the trigonometric substitution, and in this particular example, we are still going to leverage the techniques or some of the tricks, um, the methods that we employed in previous episode. All right, so let's get going. So we kind of studied quite a number of expressions that we have to look out for when we are trying to make use of the trig, substitutions. Okay, very good. So let's get going. And in this case, we are going straight to the point. So let's get going. So over here, you can see that the expression in the denominator is of this form, which is a squared plus x squared. Okay. All right. So which is related to the root of x squared plus 4. Okay. And this can be written as what? If you want to match this, this can be written as what? X squared plus what? 2 to the power 2. Okay. And we saw that if you want to use this, if you have this expression, that the best substitution to use will be what? Will be x equal to what? A tan theta, right? Okay. Where theta should lie between what? Negative pi on 2 and then pi on 2. Okay, very good. Now, in our case, what is our A? Our A in this case is what? Is 2, okay? All right, so let's get going. Good, 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 good. Now, then what is our dx? Our dx should be what? 2 sec square theta, okay? D theta. Very good. Because when you differentiate, tan, you get sec squared, right? Good, good, good. Let's get going. Now we need to further simplify our given expression, which was x squared plus 4, okay? Now, what is our x? From here, we know our x is what? 2 tan theta all squared plus 4, okay? So if you really want to really have deeper insight or get a background in our previous episode, we kind of talk about that. So you may want to visit that. Okay, so when we kind of simplify this, you should have the root of 4 tan squared theta plus 1, okay? And when you simplify this further, you should have the root of 4 sec squared theta. And what is this? This is what 2 sec theta, and that is sec theta, okay? Good, good, good. Let's get going. And at this point, if you have not subscribed to my channel, please do so, like, comment, and help spread this good news. Share it with your colleagues, with your loved ones, and let's help demystify the myth around mathematics as well. So let's get going. So when that happened, then we have the integral of the x over the root of x is a squared root of, okay. Now, what is our dx? From here, our dx was what? From here, our dx was 2 sec squared theta d theta, right? That was what we had for dx. And then what is our x? Our x already we know is for 2 tan squared. So when we square that, we should have what? 4 tan squared theta, and then the root. And when we simplify this, which is right here, when we simplify, we had what? We had 2 sec theta, okay? So let's have that in mind. And when you simplify this further, you should be able to have, so we can pull out the 1/4. When you simplify and you pull out 1/4, we should have the integral of that over tan squared theta theta. Now, to evaluate this trigonometric integral, we put everything in terms of sine theta and sine theta and then the cosine theta, okay? Because we know that let's do some algebra here. We know that sec theta over tan square theta. We know that sec is the same as what 1 over what cosine theta, right? And then the tan squared should be the same as what sine squared theta over what cosine or squared theta. Okay, good. And then of which we can do some simplification by simplifying. You should sorry, I just swapped there. Sorry, I swapped there because if I multiply, then I have to do the reverse, and by reversing, I should have something like this. Sorry. Okay. Remember, tan theta is always equal to what cosine theta over sine theta. But because now tan is the denominator, what we have to do we have to reverse it. Okay, by reversing, we should be able to have this. Okay, and then when you further simplify, you do some cancellations. You should be able to have what cosine theta over what sine squared theta. So let's take note of that. Very important. Take note. Now, therefore, making the substitution u equal to sine theta, we have, so over here, we are going to, so which means that let me write it. So before we continue. So now the whole of this can now be written as what? As cos theta over sine what square theta d theta. Okay, good. Now we want to make a best use of substitution. Okay, so now we want to make another substitution. Very important. That's the nature of this problem. It's kind of substitution, okay? You have to be used to that to be able to solve this. All right. So let's make another substitution. So let's say let u, because as it stands, it's not easy to solve this directly. So unless we make the appropriate substitution again, okay? And by doing so, we can say let u to be equal to maybe sine theta, okay? Because it will be easier to cancel, okay? To do some cancellation. And which case we're going to have our du to be equal to what? We cosine theta, okay? Very good. So now we have something this, and then you have this squared times now over here, remember we need the theta here, okay? We need the theta here instead of the du. So which case our d theta should be equal to what du over cosine theta. Okay, so du cosine theta. Okay, very good. So we can do some cancellation, and by doing some cancellation, we're going to have what? You're going to have 1 out of 4, which is called out, and du u squared. And this, when we simplify this, this is, and when we solve this, we should have what? Some plus some constant, okay? Now, what is u? Our u is what? U was given us what sine. That was the appropriate substitution that we made. Okay, very good. So now this is our result. So it means that our result is 1 minus 1 out of 4 sine theta plus some constant. But remember that we kind of transitioned from the x variable to the theta as another appropriate variable for the transition. Okay, so we have to do the reverse substitution. Okay, Okay, very good. So let's take note. Now we may want to look at this. Remember that our x was equal to 2 tan theta, okay? Our x, remember that our x was equal to 2 tan theta, okay? Now, um, it is best that um we kind of look at it from a different angle, okay? Okay. So now what that we need is what is sine theta, okay? All that we need is sine theta. But remember that with tan, so it means that my tan theta should be equal to what? Let me move it. My tan theta should be equal to what? My tan theta should be equal to what? X on 2. Remember this in algebra there's this slogan some tricks that we use to remember the trig identities and all of that. And we remember that the tan is always equal to what? Twa. Remember, if you remember this. Very good. So we want to draw, okay? We want to draw. And by drawing, we want to have something this, okay? Now, if this is your angle and this is your base is what is 2, and then your opposite will be what? Will be x. So if that's the case, it means that your hypotenuse should be equal to what? S squared plus 4. Okay? Very good, very good, very good, very good. Now, how do we get our sine? Now we need sine theta. What is sine theta? Remember the slogan or some of the things we used to say when we want to remember the trig identity, we use a so for the sine theta, we use the word so, which is opposite over the hypotenuse, okay? Which is the opposite over the hypotenuse. And then from the diagram, we know that our opposite is x and the hypotenuse is the square root of x squared plus 4. And then, remember that in math, we don't normally want to have the radical and that as the denominator, okay? So we have to do conjugate, okay? By conjugating, we're going to have x times x root of x squared plus 4 or around x squared plus 4, okay? Very important. Let's take note of that. All right. Now it means that our problem is finally solved. Okay, our problem is finally solved. Now, the problem that we're given now, if we wanna continue, our problem that we're given now, remember, we're given this problem to solve. Now, remember, this is where we go to, right? We go to -1 out of 4 sine theta plus some constant, right? But then the sign is giving us this. Now we have to kind of do some nice, reciprocation, okay? So by reciprocating it, we're going to have x squared plus 4 or um or dividing x root of x squared plus 4, okay, plus some c. But then, as I mentioned, we normally do not want it this way, so we still go further to reciprocate it. And by doing so, we should have, and when you do your simplification, we should have something beautiful as this, okay? So this brings us to the end of today's example. And as I mentioned, if you're not subscribed, please do so. Comment, turn on your notification button so that anytime I release new content, you'll be the first to receive that. And please let's help share this content to our colleagues, to our loved ones. There are people who are struggling, and I believe this content has come to save a lot of people. Please let's do help. Thank you so much for your time. Bye bye.